All right, for section 2.3, we're working with linear equations, how to write equations and identify them based on their slopes and their y-intercepts. So for the first 4 examples, we're going to classify the lines based on slope and y-intercept. So the first thing you want to do for these examples is you want to graph them. And so to be able to graph them, I have to determine the slope, which is the 4, and the y-intercept, which is -3. So from Algebra 1, you should remember your slope-intercept form, where m is always the slope. It's always going to be the number next to the x, and b is the y-intercept, which is where the the line crosses the y-axis. So for my first equation, if I want to identify the slope and y-intercept, my slope for this first equation is 4, and my y-intercept is -3. So I am going to graph my equation based on this. You always start with the y-intercept. You always put that on the y-axis. So on the y-axis, I'm going to place the point at the -3. And then I'm going to use the slope to find more points that go on that line. So my slope is 4, but if you remember, if you want to change that into a fraction, you just put a 1 underneath. So now I know the rise and the run. Now I know that I have to go up 4 units and 1 to the right. So from that starting point, the -3, I'm going to go up 4 units and 1 to the right. I want you to put at least 3 points. So one more time, up 1, 2, 3, 4, and then 1 to the right. Once you have those 3 points, you can connect them with a ruler and extend your graph. And that's your first line. So it's just graphing. For this one, I cannot graph it until I change it to slope-intercept form. I need to get the y by itself. So I'm going to solve this equation, get the y by itself. First thing you would do is get rid of the x's. Since I have -4x, I'm going to do the opposite. I'm going to do +4x to both sides, and that's going to cancel out. And so now I have y equals 2 plus 4x. You do not add those two because this one has an x and this one doesn't, so I just copy them. Y is now by itself, so now I can identify the slope and the y-intercept. So for this equation, my slope is 4 because it's next to the x, and the y-intercept is 2 because it has no x. So same thing, I'm going to start by plotting the y-intercept at the 2. And then I'm going to use my slope as the same thing. 4 over 1. So that means up 4 and over 1 to the right. Up 4, 1 to the right. One more time, once you have your 3 points, you connect them with a ruler. And then you'll be able to tell that those are parallel lines because they will never intersect. You remember from the last unit, we have parallel lines with the same slope, but for them to be parallel, they also have to have a different y-intercept. So that's just one thing that we're adding to our list of things we know for parallel lines. So I want you to write that down at the bottom of your example. For this, parallel lines have the same slope, which would be the m, but they have to have different y-intercepts. Which would be the b. We're going to do one more example. for this video. So for this one, same thing. I have to identify the slope and the y-intercept. So for this one, my slope is the -3 because it's next to x, and my y-intercept is the 2 because it has no x. Before I graph it, I'm going to solve this one. So I need to get y by itself so I can identify the slope and the y-intercept just like I did on the first one. So first step, just like I did on the first example, is to get rid of the x's. So I'm going to do the same thing here. Then I get rid of that x. Opposite of minus is plus. I'm going to do plus x. Cancels on both sides. I'm left with the 3y on the left side. And on the right side, one more time, those two are different terms, so you just keep them like that. 6 plus x. Now I have to get rid of the 3. So this is division. Divide by 3, and every single term gets divided by 3. So now I just divide 6 divided by 3. That gives me 2. And then right here, even though you don't see it, there's a 1 right there. 1 divided by 3. That's 1/3. And you keep the x. So now I can identify the slope and y-intercept. So my slope here is 1/3 because that's the number with the x, and my y-intercept is the 2. So now I'm going to graph my lines. Okay. This one that I just solved, my slope is 1/3, my y-intercept is 2. I always start with the y-intercept. So on the y-axis, I'm going to put the point on the 2. And now the slope is telling me to rise 1 and move 3 to the right. So up 1, 3 to the right. Up 1, 3 to the right. That allows me to put more points. Once I have at least 3, you connect them. So there's my first line. My second line is this one. Again, same y-intercept, so I'm going to start with the 2. But now I'm going to go down 3 units because it's negative, and then 1 to the right because it's positive. So down 3 units, 1, 2, 3, 1 to the right. 1, 2, 3, 1 to the right. And now you connect them. From your line, for your graph, you can tell that your lines are perpendicular because they intersect at 90-degree angles. You can also tell by your slopes. If you look at the slopes, this one's -3/1. This one's +1/3. They're opposite because they switch signs. And they're reciprocals because they flipped. So they're flipping. This is perpendicular lines. So write that down, perpendicular lines. You already know that perpendicular lines have opposite, reciprocal slopes, but the B doesn't matter. So you could have the same y-intercept like we did right here, or you could have a different y-intercept. As long as they have opposite reciprocal slopes, then those are perpendicular. On the next video, we're going to talk about coinciding and intersecting lines.